Hi, this is Mr. Cutchell. I'm sorry it took me so long to get this posting up today, but I was reading a book about anti-gravity and I just couldn't put it down. Well, today I'm here to talk to you about scientific notation. And scientific notation is a way to take really large numbers or really small numbers and write them in a way that makes them easier to understand and easier to see. So, an example of this is when you have a penny. A penny contains a huge number of atoms. In fact, it's a 2 followed by many, many, many zeros. And it contains that many because the average size of each of those atoms is very, very, very small. And if I were to read the number, it's 0.00000003 centimeters. That's a pretty long number to write. So we can shorten that up. And we do that by using the powers of 10. We multiply by the powers of 10 and we can create shorter numbers out of very long numbers. So here's the rules of scientific notation. You might want to take a look at these and write these down. So for any number to be in proper scientific notation, the number must be between 1 and 10. It can't be less than 1 or more than 10. The first number has to be between 1 and 10, and then it's multiplied by a power of 10. So at the very bottom of the screen it says 23 times 10 to the 5th is not proper scientific notation. Why is that? Well, because the 23 is not a number between 1 and 10. To write this correctly, we would need to do the following. We need to take this and write it as 2.3 times 10 to the 6th power. And that would be in scientific notation. Therefore, looking at our previous numbers we were looking at, that big number, the number of atoms there are in a penny, the 2,000,000,000,000,000,000, can be rewritten as follows. It's simply 2.0 times 10 to the 22nd. And 2.0 times 10 to the 22nd, it's a lot easier now to understand what's going on. If I go back up here and I look, if I put a decimal point over here, then I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. That decimal place moves 22 places. So, in general, when we talk about a positive exponent, it means you take, and when you write it out, you take this 22 and you are going to move this decimal point 22 places to the right to get your original number. So think positive to the right. And if we take a look at that other number, 0.0000003 centimeters, we can rewrite it as follows. 3.0 times 10 to the minus 8th. Again, if we take a look at this number, we are going to be going 1, 2, 3, 4, 5, 6, 7, and 8. Why 8? Because there has to be, this number has to be right here. That's between 1 and 10. So we write it as 3.0 times 10 to the minus 8th, and the negative 8th now tells us that we are going to move this decimal point 8 places to the left. So, a negative exponent means move the decimal to the left. Easy way to remember this is just think about the alphabet. If you look at the alphabet, over here if we've got L, that's closer to N. So a negative exponent, you move to the left. So negative exponent, move it to the left. And if we think about the alphabet here, P would stand for positive, and R would stand for the right. So positive, move it to the right. So let's go ahead and just take a look at how you could convert these. 4,000 would be 4.0 times 10 to the third. So this is standard notation. We call it standard notation. We've converted it to scientific notation. If we have scientific notation and we want to convert it to standard notation, this would be 5. Move the decimal 3 to the right. It would be 5,000. Down here, we're going to change scientific notation into standard notation as well. It's going to be 0.00248. Again, notice in the original number, it was a negative exponent, so I moved it to the left. And finally, the last one is going to be a positive value. I'm going to go 2.48 times 10 to the third. Now, one problem many students have is using their calculators correctly in using scientific notation. So you might have a calculator that looks like either one of these. And the important keys here are going to be either the exponent button right over here or the exponent button right here. Now to get to that exponent button on this calculator, you need to hit second function and then the EE key. Most of you probably have a calculator that looks something like this. And it's very important that you use the times 10 to the button. And you might say, what is the times 10 to the button? Well, what I'm going to show you is going to replace the times 10 to the whatever power you have up here. So, if we take a look here, when I'm writing a number like 5 times 10 to the third, my times 10 to the buttons would be second function, and then I hit this button. It has a little comma underneath it, and right above it, it says EE. This means times 10 to the, and then you press your number, you can get your times 10 to the fifth. So go ahead and take out your calculators and try this. And I mean, truly take your calculators out and try this, because practicing on your calculator will make you better at this. So put me on pause, dig up that calculator from somewhere. Okay, we have the number 2.5 times 10 to the minus 8th. If you want to plug that into your calculator correctly, hit the following buttons. 2, decimal point, 5, and then the times 10 to the button's right here. This is the times 10 to the button, so second function EE, and then it goes -8 and hit enter. And when you do that, what it should read on your screen is the following: 2.5, a little e, -8. That's the symbol in your calculator for 2.5 times 10 to the minus 8th. Here's another one. Give this one a try on your calculator as well. This time we're taking two numbers and we're dividing them. So it's 1 times 10 to the minus 14th divided by 3.2 times 10 to the minus 8th. Go ahead and take a look there. Here's all the buttons you have to push. So what you do is you hit your 1, and then here's the times 10 to the button, -14 divided by 3.2, second function EE is again times 10 to the button, -8. And when you hit enter after doing all this, you should get the following answer: 3.125 times 10 to the minus 7th. And it will read on your calculator 3.125 e -7. When you're writing your answers down on a sheet of paper, never put e -7. Always write it out in this fashion: 3.125 times 10 to the minus 7th. So let's go ahead and try this problem. Go ahead and take and actually do this on your calculators. Don't just watch the video. Take your calculators out and do this problem. Go ahead and take 4.7, and so do that by taking 4, right there, press 4, point, 7. And instead of hitting times 10, you will now go second function, EE, which means enter exponent, 5, multiply by 1.9 times 10 to that would be second function, EE, and then 11, 1 and 1. When you press enter, you should get 8.93 times 10 to the 16th. Here's one more. Using your calculator again, we have 1, so when you come down here, press the 1, 0.5 times 10 to the, so I'm going to go second function, EE, and then 4. That means times 10 to the 4th, divided by 5.0 times 10 to the, again that's second function, E, and then negative 3. When you press enter down here, you're going to get the following. It'll read 300,000 on your calculator. That would also be 3.0 times 10 to the 6th. So your calculator in this case would give you the answer in standard notation. So try a few more on your own. You can just punch these into your calculator, put this on pause. When you're done, I'll scroll down to the answer. So go ahead and try this one. And here's the answer. Go ahead and try this next one. Put this on pause and go ahead and try this, and I'll give you the answer when you unpause me. The answer to this is 2.95 times 10 to the 9th. Again, it will read on your calculator 2.95 E9. Let's try 2 more. Try this one, put me on pause. Here's the answer. And finally, one last one. Try this one, put me on pause. And here's the answer. Well, I'm glad you learned some scientific notation today. You got your homework to do, so I need to take off. Have a great day.